In this video, you're going to learn about the main factors affecting reaction rate and why they affect reaction rate. Let us first list the main factors that affect reaction rate. Concentration, pressure, temperature, and surface area. First, we must be clear what concentration is. Concentration is a measure of the amount or number of particles in a given volume. Concentration can be increased either by increasing the number of particles whilst keeping the volume the same, or by decreasing the volume and keeping the number of particles the same. As an example, let's have a look at solution B, reacting with a solid, A. One example is hydrochloric acid reacting with marble chips. Here, the H3O plus ions from the acid react with the marble chip particles. In a dilute solution of hydrochloric acid, there are not many H3O plus particles in a given volume to react with the marble chip particles in a given time. Hence a slow reaction and a low reaction rate. In a more concentrated solution of hydrochloric acid, there are more H3O plus particles in the given volume to react with the marble chip particles in a given time. Hence, a faster reaction and a higher reaction rate. Now let us move on to pressure. As mentioned in our video on states of matter, gases can be compressed, while solids or liquids cannot. Pressure, therefore, only affects the reaction rate of reactions involving gases. Let us consider two gases, A and B, reacting to make gas C. As mentioned in our video Collision Theory and Reactions Part 1, for a reaction between gas A and gas B to occur, they must collide with sufficient energy. A collision resulting in a reaction is a fruitful collision. So the rate of reaction can be taken as a number of fruitful collisions between A and B per second. If the pressure on this reaction is increased, the volume will decrease. As mentioned earlier, this decrease in volume results in an increase in concentration. So there are more fruitful collisions per second and therefore an increase in the rate of reaction. Next up is temperature. As mentioned in the video Collision Theory and Reactions Part 2, particles need a certain amount of energy, called activation energy, for their collisions to be fruitful. In other words, for them to react. Increasing the temperature increases the average kinetic energy of the particles. This means that more of them will have sufficient energy to react, resulting in more fruitful collisions per second and therefore an increase in the rate of reaction. Last is surface area. To understand this, consider the reaction between hydrochloric acid and one marble chip. The H3O plus ions from the hydrochloric acid can react with only the surface of the marble chip. If this marble chip is broken down into two, the total mass will remain the same, but the surface area will have increased. The H3O plus ions from the hydrochloric acid can now react with more of the marble chip in a given period of time. This means the increase in the surface area results in an increase in reaction rate. So to recap, concentration is a measure of the amount or number of particles in a given volume. Increasing concentration increases rate of reaction. Increasing pressure on reactions involving gases increases the rate of reaction. Increasing temperature increases rate of reaction. And finally, increasing surface area increases rate of reaction.